figuring out what percentages is where and what we put where is the key here. So the first bit of information is known that 2 out of 5 cups of coffee, so 0.4 or 40% cups of coffee served contain more than 100 milligrams of caffeine. So 0.4 contain more than 100 milligrams of caffeine. So maybe let's start off with 100 milligrams here, and that area is 0.4, something like that. Maybe a good way to start. It is also known that 4 out of 5 cups of coffee contain more than 85. Okay, so 4 out of 5 contains, so 0.8 contain more than 85. So 85 is clearly somewhere here. And that means this area is 0.2, rather than saying that this area is 0.8. I think that's probably the better way to go with that one. So at 85.
But 85.
We don't know the mean, we don't know the standard deviation.
But what you're also saying is that this onwards is 0.8.
Yes, so this is 0.4, which means this bit back is 0.6 then as well, if you want to use that on the other hand. Okay, so then assuming under distribution, calculate the mean and standard deviation. So if you need to calculate the mean and the standard deviation, I would automatically think z-scores, and that there is a formula for that in the formula booklet. Z is x minus the mean all over the standard deviation. X in this case would be 85 and 100, and z would be the number of standard deviations they are away from the mean. Now, in general, any normal distribution has the same standard deviation for the same areas. So no matter 0.4 is always sitting somewhere like that, and will have the same number of standard deviations away. Even if let's say the mean is 0 and the standard deviation is 1. And that's what z-score is all about. The mean is 0 and the standard deviation is 1. And they will have the same number of standard deviations away as any normal distribution at 40% and above. So we have to figure out how many standard deviations, 40%, now that might be, one might be over here or here, but how many standard deviations 40% is in general. So then I do my inverse norm on my calculator, where I get my calculator and I press.
And you press the inverse norm?
I do press the inverse norm, shockingly, button. Vars, now second vars, inverse norm is number 3, second vars. And the area I'm looking to find then, well, let's find 0.2 first, because maybe it's the easier one. 0.2 is definitely this area here. So we go inverse norm, 0.2 is the area, and your calculator is almost certainly already set at 0 and 1. And we get an answer out here. And we get an answer of negative 0.841. So that's negative 0.8, and that makes sense that it would sit negative anyway, standard deviations, because it's this side of the mean. Okay, so then we can start to fill out our z-score thing here. We get negative 0.841 is for the 85 value minus the mean all over. Okay. And that's one equation with 2 unknowns. But we now can form the second equation. We're going to do something with 100. So 100 then, so what?
0.4 down right.
So we put in 0.4, what happens? We put in 0.4, you do the same one, put in 0.4, and you're, yeah, you're going to get a negative number, aren't you? Because it's working this way. So you've actually found this one when I put in 0.4, because this is actually 0.6. So if you put in 0.6, you'll get the correct answer, but 0.4 is a symmetrical answer. It's just the negative of your 0.6. So 0.4 gives negative 0.23. You want positive 0.23. So if I put in 0.4, I would have noticed, oh, that's on the wrong side. So then what's going on? Oh, I've got the symmetrically opposite one. I'm actually looking at this area 0.6, which is all this area back. So 0.6 I could put in and get the same answer. Or I can just notice that's the negative of where it should be, the reflection here. And then, okay, 2 equations, 2 unknowns, we can solve, I hope. Use substitution or elimination. solve those, you should get answers of something. 95 for the mean, or 96.5, and the standard deviation is 13.7.
Yeah, there's a 0.7, it was 6 off for both.
Okay. Next one.